Hi everyone, in this video we are going to look at how to derive the formulas for reduction. Alright, so we are saying that we are deriving the formula for reduction. So the reduction is one of the methods which is used to integrate functions which cannot be integrated furthermore by parts. So for instance, we have 6 common forms of reduction, and these forms are: number 1, we have integral of x to power n e to power x dx. Number 2, we have the integral of x to the power n e to power ax dx. Number 3, we have integral of x to power n sine of x dx. Number 4, we have integral of x to the power n cos of x dx. And then number 5, we have integral of x to the power n. So number 5, we have integral to the power, integral of sine to the power n x dx. And then number 6, we have integral of cos to the power n x dx. So we are going to look at how to derive the formulas for reduction of these forms. So now, because what happens is that if you are given a question which is in this format, for instance, it means that it can only be integrated by reduction. For instance, I can give you to integrate integral of x to the power 4 e to power x dx, meaning that this question can only be integrated by a formula which is given for this format here. Or if I give you something to integrate which is in the form x to the power 4 sine of x dx, meaning that this question can only be integrated using reduction of this format here. Alright, now how then do we derive the formula? So the main interest of this video is to derive the formulas for reduction. Let's see how we can derive these formulas. So number 1, we are going to derive the formula for integral of x to power n e to power x dx. So this is what we are going to derive here. Now whenever you're deriving the formulas for reduction, make sure that you are using by parts. So to derive the formulas, we use by parts. So using by parts, we say let u to be equal to x power n and dv to be equal to e to power x. Then from there, we say that our du here is differentiating x to power n is nx power n minus 1. And then for you to get v from the dv, you should make sure to integrate this e to power x. So integrating e to power x is the same as e to the power x. So after you've gotten these parameters, what you're supposed to do then is to put them in the formula. So the formula is uv minus the integral of v du. Then what is our u? Our u in this case is x to power n. So our u is x power n, our v is e to power x, our v again is e to power x, and our du is this one that we've gotten here. So by doing so, we are going to say that we replace our u is x to power n, our v is e to power x minus the integral of what's our v is e to power x, and then du is nx to power n minus 1. Okay, so here we multiply, we have x to power n e to the power x minus, here you can bring the constant n outside, meaning that if it comes outside the integral, it's going to be n integral of x to power n minus 1 e to power x. So what I've just simply done is this n has come in front here, and then these two now have multiplied. So whenever you're multiplying an expression just with an exponential, that expression should start. So I've started with that expression, and then the e to power x goes there. Alright, now from here what you're supposed to do is you say this is x to power n e to power x minus this n is a constant, and then the whole lot of this part, after you've reached at this stage, the whole lot of this part here is the same as integration. So it is the same as integration of n minus 1. So that means that and remember that is a subscript, so you write it like this, n minus 1, like that. It's not like a coefficient or something, but it's a subscript. So meaning that this becomes the formula for reduction of this form. So that's how we derive the formula for reduction of this form. And now then, let's see how to derive the other form for reduction. So the other form for reduction is b, which is the integral of x to power n e to power ax dx. So how do we derive this? So to derive this, we are also going to use by parts. So you say let u to be equal to x power n and the dv to be equal to e to power ax. Then from there get du. How can we get du? You have du is equal to, remember how to differentiate, this comes in front and the power reduces by 1. So it's going to be nx to power n minus 1. And then for if we are given dv, for us to get v, meaning that we are supposed to integrate the e to power ax. Integrating e to power ax is you have only, you differentiate what is on top, which is a, but it will come as 1 over a, and then you multiply with everything given, which is e to power ax. Then after getting these parameters, we need to replace them in the formula for by parts. So the formula for by parts is given as uv minus integral of v du. What's our u? Our u is this, our v is this, our du is this, so we're just replacing there. So by replacement, we have our u, which is x power n, our v is 1 over a e to power ax, so 1 over a e to power x, which is here, then minus the integral of v, which is 1 over a e to power ax, and then du is this n x to power n minus 1. So we put n x n minus 1 like that. So from there, you need to bring the constant, which is n times 1, this n here, times this one, which are constants, becomes n over a. So you're going to have x to the power n, and then the 1 over a also can come out, which is like this, 1 over a x to the power n e to power ax. So I've just written this one here, which is this, and then we go to minus. Here we have 1 over a, and the n, when they are to multiply, you are going to have n over a, then integration of x to power n minus 1 times e to power ax. You are going to have x to power n minus 1 e to power ax. So after you've done that, you have 1 over a x to power n e to power ax minus, you have the n over a. Now everything that is remaining this side can be represented by integration capital I of n minus 1. Alright, meaning that the integration or an integral which is having a term of n minus 1 there, so no wonder we write that. So that means also that we've derived the formula for reduction of this form here. Now let's try to go to the other form of reduction. So the third form of reduction is where we are deriving the formula for x to the power n sine of x dx. Remember, we are saying that deriving the formulas, we are still using by parts. So we are going to say let u to be equal to x to the power n and the dv to be equal to sine x. Then from here we get du. Our du is nx to power n minus 1. Then dv, for us to get v, we just need to integrate sine x, which is going to give us negative cos x. So by doing so, you are going to write the formula for by parts, which is uv minus the integral of v du. Then we have uv is equal to integral of v du. So after you've done that, you replace. Where there is u, you put this. Where there is v, you put that. Where there is v, you put that. And where there is du, we are putting this one there. So let's do that. So we are going to say that we have our u, which is x to the power n, v is negative cos x, minus the integral of v, which is negative cos x, and then du is n x to the power n minus 1. So by doing so, you have x to the power n negative cos x. Negative and negative here is a positive. Then the n which is here can come outside, or maybe let's keep it the way it is first, which is integral of n x to the power n minus 1. Remember, even when you keep it there or you factor it out, the answer is just the same. So then the cos of x like that. Okay, so I have just rewritten this one I've written this one here, this part here. Okay, so this n is here, x to power n to minus 1 is this one, and the cos x is this one. That negative is this one, which has given us the positive. All right, so from here, now at this point, this one is different from the rest that we've done on top there, where we end here to say integration of n minus 1. No, for the x to the power n sine of x, when you are using this form here, you need to make sure that you also need to integrate this one further. So you need to use again by parts. That's where now you end when you integrate it twice. So that's what we do. Okay, so by doing that, we keep this one, which is x to power n times negative cos x is going to be negative x to power n cos of x. Then plus, here we have the integral of n x to power n minus 1 cos of x. So we are going to now integrate this part here. Integrating this part, we are going to keep the negative x to power n cos of x, then plus plus we come here. So when you are to integrate here, we are using by parts again. So keep it. I want you to keep it. Don't forget. Let me even underline it. You keep this one. We are going to integrate this one by parts again. So integrating that by parts again, we are going to say that let u to be equal to n x to power n minus 1, and then our cos x like that. Okay, which is our dv. So our dv is equal to cos x, in other words. All right, so this is our dv, which is equal to cos x. Then from the u, get du. So du is this multiply with what is here in front. We are going to have n open n minus 1. Hope you've seen. I've multiplied what is on top there. Remember, we are differentiating, so we multiply the power with the coefficient and the power reduced by 1, which is going to be x to the power n minus 2. If the power reduced by 1 there, it is going to be minus 1, which is n to the power negative 2 there. Then if we are given dv, for you to get v, you need to integrate the cos x, you get a positive sine x. So after getting these parameters, what you're supposed to do is to replace them in the formula. So the formula is uv minus integral of v du. So our u is n x to power n minus 1, which is this one here, which is this one. All right, like that. And then our v is sine x. So you write sine x there. So you write sine x minus the integral of v, which is sine x, du is the n open, n minus 1. Then okay, we have n here, n minus 1 x to power n minus 2, like that. Now we say this is n x to power n minus 1 sine x minus, you have this one here, which you can write as the integral of the n minus 1 can come in front, by the way. So if you want, the n minus 1 can come in front, where you say n minus 1, the n open, n minus 1 is a constant. Then you say integration of x to power n minus 2 sine of x. Okay, so I've just brought this one in front, which is this one, and then this is this, and the sine x is that. So at this point now, that's when you say this is n x to power n minus 1 sine x minus, you keep this constant, which is n open n minus 1, and then everything which is here from here to here, you say integration of n minus 2, meaning that we have the part which is having the n minus 2 on top there. That's what you have. So from here now, remember, we kept which one? We are just integrating this part, but we kept this part. So the answer that we've gotten now for this, we need to add it there. So I'll get first this one that I kept, which is negative x to power n cos x. So negative x to power n cos x. And then the answer that we've gotten to integrate this part is this one here. So we add it. So we're going to add it, which is plus n x to power n minus 1 sine x minus n open n minus 1 integration of n minus 2. So meaning that this becomes the formula for reduction when it is in this format here. All right, now what you do is that Remember, we also had the integral of x to power n cos of x dx. So what I've done is I've just solved this one. I've derived the formula for this. Now, if you know how to derive the formula for this, meaning that you can also know how to derive the formula for this one. So since I've done these where I'm saying that they are similar, meaning that I can give you the other one to be your task. So your task is derive the formula for reduction of this one here. All right, so what I'm saying there is your task is to drive the formula. So drive the formula for reduction of the integral of x to power n cos of x dx. So if you've just understood how to drive this one here, if you've understood how to drive this one, meaning that even this one will be the same, because what they have just changed there is the sign and the cos, but the whole procedure will remain the same. So from there, we are going to look at also driving the formula for reduction of the form cos to the power n x dx. Now, here, if you know how to drive this one, meaning that also you can be able to know how to drive the sine to the power n x dx. So we are going to pick one. Which one should we pick? Let's pick let's pick even this one here, which is the integral of sine to the power nx dx, right? Or even this one, there's no harm. So if we are to pick this one, what we're going to do is we are going to say that we have the integral of cos to the power n x dx. Now, driving this one, it's a bit different from the others. These two, it's a bit different from the others. Why is it different from the others? It is different because remember, we are driving using by parts, and driving by parts, it means that you need to, when you are, if you are to drive this by parts, meaning that you need to have two functions, but in this case you only have one function. So to make these two functions, what you're going to do is simply to divide this into two. So dividing this into two, you are going to say that this mathematically, according to index notation, is you can say this is the same as cos to the power n minus 1 x, then cos of x dx. This means that if I rewrite this function in two functions here, I have the same powers here. Here the power is n minus 1 and the power there is 1. So if you are to add, if you are multiplying something of the same bases, you just need to add the powers. So you keep the cos and then you add n minus 1 plus 1, n minus 1 plus 1, like that, meaning that you are going to have cos of n, and 1 will go because one is negative, another one is positive, meaning you remain with the cos to the power n x, like that. So this means that for you to be able to reduce the formula or to drive the formula for reduction of this form, you should start by rewriting this format in this form here. So after you do this, that's when now you can be able to reduce the formula here using by parts. So let's do that. So by doing that, we are going to say let u to be equal to what is our first function here, which is a cos of n minus 1x, and the other function to be dv, which is a cos x. So if we are having u here, meaning that you can get du. So our du is, now getting du there, you need to use chain rule. Differentiating, you need to use chain rule because this can be written as cos x to the power n minus 1. So using chain rule here, what you're going to do is you say our du is equal to the n minus 1 comes in front, which is n minus 1, and then we have the cos to the power, so the cos x to the power n minus 1. But you need to also differentiate what is inside and multiply here, which is going to be a sine x. Okay, so that is how chain rule works. So I have multiplied the power with the coefficient, which I've done here, and the power has reduced by 1. So the power is going to reduce by 1, which is going to be n minus 1 minus 1, like that. And then after you've done that, don't forget to multiply what is inside, what you've gotten with the derivative of what is inside, which is a sine x. So by doing so, we have our du, which is equal to n minus 1 cos to the power n minus 1 minus 1 is cos x to the power n minus 2 and then sine x, like that, which can actually be written as du is equal to n minus 1, then cos, this cos x to the power minus 2 can be written as cos to the power n minus 2x, then sine x, like that. So by doing so, we are going to now, so I've said that we have our u, and then we've gotten the u using what? Chain rule, because you cannot just differentiate this one direct. You need to use what? The chain rule. So this is the chain rule, and just I've gotten is this one. Now from the dv we should get v. So getting v from the dv, we just integrate. Integrating a cos x is what? A positive sine x, like that, like that. Then from there, you need to replace these assumptions in the formula. So we have this as our du, this as our v, that's our dv, and that as our u. So by replacing them, we have uv minus integral of v du. So our u is this one here, which is cos. So it is cos to the power n minus 1x. Our v is this one here, which is a sine x, minus the integral of v, which is the same sine x. Du is this one here, which is n minus 1 cos to the power n minus 2x sine x, like that. Then from here now, what we're going to do is we multiply, which is cos to the power n minus 1x sine x, minus, here what we can do is that we have the n minus 1, which is a constant. It can come outside. Okay, it can come outside. All right, so it can come outside, which is going to be n minus 1. Then integration of I do that integration of, I multiply the sine x, see this sine x and the sine x, we are going to get a sine squared x. So we get a sine squared x, like that, and then the cos of n minus 2x. Okay, so hope of seeing that. I've multiplied this and that to get this, and then this is this one. The n minus 1 is the one which has come outside. Then from there, what we're supposed to know now is that you need to get the identity for this. So identity for that, you know that, in other words, I want to make sure that what is here, since we have a cos here, you need to make sure that this one also is transformed to cos. How can you transform it to cos? You can use the identity, which is sine squared x plus cos squared x is equal to 1. So if you are to make cos squared, sine squared x a subject, you are going to have a sine squared x is equal to 1 minus cos squared x. Meaning that instead of us keeping this sine squared x here, we can instead replace it with that. Alright, so by doing so, we are going to have a cos to the power n minus 1x sine x minus n minus 1 integration of, where there is sine squared x, we are putting 1 minus cos squared x, and then times cos to the power n minus 2x, like that. Then we need to multiply now this cos to the power n minus 2, this one here to this, and also to that. So let's do that. So by doing that, we're going to keep this, which is cos to the power n minus 1x sine x minus the n minus 1 integral of, we multiply cos to the power n minus 2x times 1 is cos to the power n minus 2x, minus, we also multiply cos to the power n minus 2x times cos to the power n. This and this have the same bases, they have the same base. So this and this, they have the same base, meaning that they can just maintain their base and add the numerators. So the numerators are n plus n minus 2, where you have all right, so what we are going to have there is, okay, let me just check if what I've done, oh, this is a 2 here. I think I made a mistake here. Here we have a power of 2, because we are saying that where there is a sine squared x here, we are putting the cos to the power 1 minus cos to the power 2x, which we've put here. So meaning that as we are adding, we are just maintaining the base, and then we add the powers, which is 2 plus, so it will be 2 plus n minus 2, which is this, and that will go. then we are going to remain with only a cos to the power n x. Okay, that's what we're going to do. Then from there, now you've seen that the n minus 1 is common to this, also to that, so you can distribute it again. Also, the integral is also for this and for that, so you can also distribute the integral. So we shall end up having cos to the power n minus 1 x sine x minus, you distribute this to that, you're going to have n minus 1 integral of cos to the power n minus 2 x. Then you also distribute n minus 1 times this, you're going to have n minus 1 like that, but don't forget the integral. So let me just do this so you don't forget the integral. So we do this, we say minus, we also multiply this times that, we're going to have the n minus 1 and then integral of cos to the power nx. Okay, so I've distributed this to this, also this to that. Okay, what I'm distributing is only this, the negative is remaining the way it is. So don't say why is this negative not changing, because I've kept it the way it is, and then that one is just like that. So by doing so, you once you reach at this stage, what you do is you say, I'm integrating, the one that we are integrating is, we are driving the formula for this form. So you say, I'm driving the formula for cos the power nx dx, which is equal to, the answer that we've gotten is cos to the power n minus 1x sine x minus n minus 1, then integration of cos to the power n minus 2x, then minus n minus 1 integration of cos to the power n minus nx, like that. So by doing so, what you need to do now is to correct like terms here. So if you have to correct like terms, what you're going to do is, you've seen that this one and this one at the far end there, they are like terms, because we have cos to the power nx, here also have cos to the power nx. So this one can cross the equal sign connecting to this one here. So if this is a negative, then when it comes here, it becomes a positive. So by doing so, you're going to have integral of cos to the power nx dx plus, it becomes now a plus, this one is the one which is coming the other side, which is going to be plus n minus 1 integral of cos to the power n minus, nx there, so to the power n x, like that, dx. Okay, so I've brought this one here to this side. Then what are we going to remain with this side? It's only this from here to here, like that's what we're going to remain with there. So we're going to say is equal to, so we're going to say that is equal to, so this is equal to the cos to the power n minus 1x sine x, then minus n minus 1, and then n minus 1. Don't forget that there is the integration of cos to the power n minus 2. So the integration of cos to the power n minus 2 x, like that, like that. Okay, now here you have this one and this one are like terms. So if these are like terms, what you can do is that you can just keep the cos. Remember, if I give you to say 2x plus 2x, you keep the x, you just add the 2 and the 2, you get 4. Even here you have the cos and the cos are the same, meaning that you keep the cos to the power nx dx, and then you just need to add the constant here and the constant here. So here constant is 1, here the constant is n minus 1. So you add the 1 plus n minus 1. So by doing that, if you add 1 plus n minus 1, you're going to have this and that will go, meaning that you just remain with the n here. Alright, so you're going to remain with n integral of cos to the power n x dx. That's what you're going to remain with. Okay, so I'm saying that we are going to remain with, so let me just remove it here. We are going to remain with n integral of cos to the power nx dx. So that means that we've added this part and that part. I'm saying that adding these two, just maintain one of them and add just the coefficients. So here coefficient is 1, here it's n minus 1. Adding them, you get n, like that. Then this is now equal to the cos to the power n minus 1x sine x minus n minus 1, Now this type of this point here where you have integration of cos to the power n minus 2 can just be written as capital I and n minus 2. Okay, so now remember we are integrating, we want to derive the formula for cos to the power nx dx, and we still have the n there. So what do? Divide the n throughout. So if you have to do that, we have over n over n over n. So that means this and that will go, and then we end up having our final answer, which is the integral of cos to the power nx dx is equal to, we divide it is going to be 1 over n cos to the power n minus 1x sine x minus n minus 1 over n integration of n minus 2. Alright, so this is what we are going to have as our final answer, meaning that this becomes the formula for reduction of this form, which is x to power cos to the power nx dx. The formula that we use is this one here. Alright, so that's how to drive the formula for reduction of this format. So now since we've derived this one, I want you to drive the one for sine. Alright, so feel free to solve the work and send either on my Facebook page inbox or just on WhatsApp if at all you have my number. Of course, my number is there on my bio. Alright, thank you so much for watching my videos. Please don't forget to invite friends to follow the page, and also, just leave a like after watching. Thank you so much. See you next time.